Welcome, dear friends, to a new adventure. I'm pleased to start with you once again. We are facing the study of the technical thermodynamics, that is, the thermodynamics for engineering applications. Of course, there is much in common with the classical thermodynamics, but we will afford some simplifications and restrictions to adapt it to solve practical problems of the system and machinery engineering. Definitely, we start from the basic definitions, the first and second principles of the thermodynamics, well known, the concepts of work, heat and efficiency, and we apply them for the most common fluids of technical interest. We will learn the meaning of ideal gas, perfect gas and real gas, and which model to apply in the different cases offered by practical problems. Finally, we also simplify the equations and the calculations as much as possible, using standard approximated formulas whenever possible, and when not possible, we use some dedicated tools I will introduce later on. Let's start. Let's see briefly the content of the seminar. First, we see the definitions of the thermodynamic variables. Then we speak about the first principle, the equivalence between work and heat, then the second principle with the different formulations. Finally, we learn the thermodynamic cycles and we make examples of machines used in the practical life. How to deal with mixtures of gases and gas plus steam, and then we start with some applications. The vacuum generation by steam, the steam generation without combustion, the vapor recovery and recompression, the air compressor centrifugal and lubricated type, and the jet pump. The arguments listed here are just for reference. They can be added more or they can be slightly different in the content because the presentations are still not ready. Moreover, it can be that one argument is covered by more than one presentation, as surely happens for the thermodynamic cycles. However, if you have a specific interest for an argument, please write me in the video comments and I will take it into consideration. What is technical thermodynamics? What is the difference between the classical thermodynamics, let's say CT, and technical thermodynamics, TT? In summary, CT relies on equilibrium states and idealized processes, often reversible ones, while TT incorporates real fluids behavior and irreversibility, and focused on efficiency. CT uses general equations based on state functions, while TT does not use complicated formulas, mostly property tables, apps and diagrams. CT is often neglecting losses and any cycle is interesting, while TT is interested in losses, when important of course, and focused on cycles of practical interest only. Are there synergies among the two disciplines? Of course, there are many. CT tells us which principles and laws we need to use, while TT adapts laws to engineering design and application. Here we make a short list of tools which will accompany us during the course. This is not exhaustive, however. The first application is for displaying the steam charts and is called steam plot. For the simulation of the refrigeration cycles, both chillers and heat pumps, we use two applications. One is fly carpet and the other one is TLK energy. For the search of the fluid properties, we have the IRC fluid property calculator. And for all the thermodynamic cycles, we use the application Thermonator, which is available for Android users. Whenever those or other applications will be called, it will be said during the course. The links are also available in the video comments for easy retrieval and use. We see now the applications in detail. The steam plot is very simple to use. There are many charts. The results can be exported into text. That is very comfortable. But there are only states, no transformation, no work or heat, no cycles calculations, and no efficiency. The fly carpet for the refrigeration cycles is including many cycles, also the complex ones. Efficiency calculation is given, and you can represent both the pressure enthalpy and the temperature entropy diagrams. Unfortunately, there are only few refrigerants available, and few of them are old ones, not any longer in use. The TLK energy is also for refrigeration cycles. It is simple to use. There are many gases, also the newest ones. The efficiency calculation is also displayed, but it can be used only for very simple cycles, and it does not make any work or heat calculation. The IRC fluid application is only for the properties, does not make any cycle calculation. It is simple to use, many properties are given. You can choose either international system or imperial units, but unfortunately there are only very few fluids available. The thermometer is for the thermodynamic cycles. Honestly, it's my favorite application, very comfortable for didactic purpose, very simple to use, many charts, many fluids, all possible gas types, ideal, perfect and real, all possible thermodynamic cycles with all the information, work, heat, efficiency, and the results can also be exported into text. There is only one big disadvantage, that this is only for mobile and Android users, no PC, and therefore the charts are small with a low resolution. Some definitions. What is an ideal gas? Is a gas where the specific heats are constant and the thermodynamic variables pressure, temperature and specific volume are linked by a state equation. A perfect gas is a gas where the specific heats are depending upon temperature only, not any longer constant, but still the thermodynamic variables are linked by a state equation. In a real gas, the specific heats are depending not only upon temperature but also pressure. The thermodynamic variables are linked by a state equation, but it can be different from the one used above, and appears also a compressibility factor Z. A vapor is a special gas. I would say it's a real gas because the specific heats are depending upon temperature and pressure, but the temperature and pressure in saturated region are dependent each other. A state equation is still existing but more complex. Still, two independent variables are needed to define the state, but in this case, in the saturated region, we introduce a new variable, which is the vapor quality. Same as we did for the Astro course, we will demonstrate time by time the formulas that we need to use in our applications, and eventually we collect them in a table for easy retrieval. The formulas will be the ones needed to solve our problems, and we will try to make them simple as much as possible.